So we're going to continue with our discussion of factoring here. Now, when we factor these polynomials to solve them, we're always going to start with our greatest common factor. And then in general, we have, not in general, but quite frequently, we have three-term quadratic trinomials like this guy. And so we know how these things factor. They always factor as these two binomials in parentheses, if they're going to factor and they aren't prime. But sometimes when we take out that GCF, we do not have a trinomial. Instead, after we take out the GCF, we end up with a binomial. And that binomial, hopefully, it's not always, hopefully is one of these special binomial factorizations. Now notice what they're called here. They're called a difference of squares. So here's a two-term binomial with a minus sign and two terms that are squared on each side. And it shows us how to factor that. And if we got two terms and it's a difference of cubes, so a minus sign and two cube things on each side, shows us how to factor that. Notice it's a little more complicated factorization. This is the first time we factored and had a binomial and a trinomial. And lastly, we could have a sum of cubes. So again, we're still going to do this GCF business, but we have a decision to make here. Okay, after we do GCF, do I go down the binomial path and use one of these special factorizations, or do I continue on this trinomial path? So it just depends on the problem. So let's look at a few of these binomials and how to factor them. So here we've got a few binomials, and I've got my factorizations that we should memorize, but in particular, we want to make sure we have the first one memorized. It's a very simple one. We've actually seen this. These were these binomial conjugates. And we saw that when we multiplied them, we got these a squared minus b squared. So now we're just going in reverse with them. But anyway, this one should be memorized. These other two, the difference of cubes and difference of sum of cubes, I would give you those formulas, but it's going to be important then that you know how to use them. So let's take a look at this one in red here. I see I've got two terms. I see it's quadratic, an x squared equation. And so if it's going to be one of these things, it's probably going to be this difference because it's got the minus sign, and I can see a squared. But 9 is not shown as something squared. It's just a 9 to the first power, and the 64 is just 64 to the first power. So our first step is, of course, I've checked for a GCF. 9 and 64 not divisible by anything. So what we're going to do is we're going to see if it is indeed a difference of two squares. And what do we mean by that? It means, can we write 9x squared as something squared? And the answer is yes, we can. At 3x, if you square it, you get 9x squared. And 64 is a perfect square also. It is an 8 that has been squared. So 3x squared is still 9x squared, and 8 squared is still 64. But now by writing it this way, I should do this in a different color here. Let's use some green. So now this is my A right here, and my 8 is my B. So you can tell once you've written them what A is and what B is. And then you just have to use the formula. The formula says a squared minus b squared is a minus b, a plus b. I'm just taking that from this line right here. And so mine is, I'm rewriting it just so we can make it really nice and complete. So my factorization is 3x minus 8, my a minus my b, and my 3x plus 8. Now notice this equation equals 0. And so if we're trying to solve this thing, now that we have it factored, we just take each factor and set it equal to 0 and solve them. This was a quadratic equation, x squared. We'd expect two solutions, and we get them. I add 8 to both sides and divide by 3. I subtract 8 and divide by 3. And so I do find two answers, 8/3 and negative 8/3. And we're done. Okay, so two terms, And we hope it's one of these things. If it's not, we have to use different techniques. So I'm going to bring down this little formula sheet if I can, if it'll let me just grab that. Maybe I can grab it this way. Nope, it's all right. I've got to memorize. So let's look at this one here. Now, this thing right here, we can see we've got an x cubed there. So we're hoping that 125 is some number cubed. Okay, now you can memorize these or just generate them really quickly, but these in particular are the numbers that we want to recognize. That's about as high as we go. Okay, on our calculator, we could type in the cube root of 8, and it would give us a 2. So it tells us what is cubed to give you 8. Now, in this case, see how this 5 cubed gives you 125. So we're going to rewrite our blue binomial here as this. And that is now a difference of 2 cubes. So difference because it's subtraction, 2 cubes because they're cubed. And here is the formula for it. If you have a cubed, I don't need that parenthesis, minus b cubed, you always get a minus b, just like the difference of squares was. But then you get something kind of weird, this trinomial, a squared plus ab plus b squared. Let's get them in there, right? And so now that we know that a is x and b is a 5, we can just substitute those in. Where every time I see an x or an a, I'm going to put in the x. Every time I see a b, I would put in the 5. Just like that. Then it says take the a and square it, so I go x squared. Then it says take a times b and add it, so you go x times 5. Then it says add b squared, so that's 5 squared. And then we clean this up a little bit. Nothing to the first one, nothing to x squared, but x times 5 we write as 5x, and 5 squared we rewrite it as 25. And so this difference of cubes, x cubed minus 125, is equal to this factorization. And the whole thing equals 0. And so if I want to solve these now, I've got this factor, x minus 5. Gives me that solution. And I'd have to set this other factor equal to 0. Now this trinomial that you get, every time you get a trinomial in this difference of cubes and sum of cubes, see these trinomials there? Those trinomials every time are prime. They will not factor. In fact, if we solve this thing, this will give us 2 imaginary solutions. We'd have to use the quadratic formula on it. And we aren't going to find those right now. Today, all you have to do is find the real solutions. And so we're going to stop as soon as we find that single real one. So all of our x cubes will have that one real answer. All right, our last example. Okay, I'm hoping it's a difference of cubes. So let's see if I can write it as that. Something cubed minus something cubed. I just saw 125 is 5. 8 cubed is 2 times 2 times 2, or 8 is a 2 cubed. So there's how it factors. I can see my a is 2x, my b is 5. And again, here's the factorization. You should just get used to writing this a bunch of times and get it memorized. So difference of cubes starts with a minus b. Then you square the a, you multiply the a and the b, and you square the b. So you're squaring the a, squaring the b, and in the middle is their product. And so our a is 2x, our b is 5. We just have to fill these in now. So it's 2x minus 5. Now I have to square 2x right here. 2x squared means 2x times 2x. That's a 4x squared. Then I have to take a times b. That's 2x times 5. So I'm just going to put 10x. And then b squared, my 5 squared, is 25. And again, this trinomial is prime, so we don't have to solve that one. But the 2x minus 5, we will set that equal to 0 and solve it. You get 5/2. Add 5, divide by 2. And so that's how we factor these special binomials. Now I'm going to throw up your homework assignment here so you can see that as well. You can see our assignment is just factor the following and find the real solution or solutions. So let's look at this first one here. The first one, they've even given you a little hint here, or I have. It says rewrite it as a difference of cubes. So it's an x and 64. If you cube root it is 4, or 64 if you factor it, it is 16 times 4. And 16 is 4 times 4. So it is 3 4s multiplied together. And so here comes the factorization. Again, I'm going to write it down. Oops, not the answer, but the formula. A cubed minus b cubed is a minus b. Square the a, multiply, and square the b. And so ours is x minus 4. X squared plus 4x plus 4 squared. And the only real solution we get is from x minus 4 equals 0. So x is 4 is one of the answers. Now I'm going to pull up my calculator. Oh shoot, you won't be able to see it. Let me pull up my calculator and I'll pop the equation in there. So here comes the photo of the graph of this equation. There he is. And so you can see up here, I've actually graphed the equation x cubed minus 64. And you can see over here it crosses the x-axis in that one spot. And that is the solution. Let's see if this thing will move now. That we found. We found that solution x equals 4 right here when we did the math. Now, it only crosses the x-axis once. It does have 3 solutions to it, but those 3 solutions are inside of this quadratic part here, and we'd have to go find those other 2. All right, that should get you started. Now, the rest of these, I am going to work through the rest of these problems just so you have them, but I'll keep my commentary short, at least to get you started on these. So this would be x plus 3 cubed, and so we could factor that x plus 3. X squared. When you're doing the addition one, the minus sign goes right here. It's minus AB. Okay, so this is A plus B, A squared minus AB plus B squared. So there's the factorization. The real part comes from the x plus 3. And we solve it. So we got our factorization, and we're good to go. Let's see here. We got ourselves a difference of squares one here, it looks like. Difference. 9's a perfect square, so is 16. So 3x and 4. 3x times 3x is 9x. This is the difference of squares. It factors this way. So for us, it'd be 3x minus 4 and 3x plus 4. This gives you 2 answers. You'd have to solve them. I'll let you do that. Set 3x minus 4 equal to 0 and 3x plus 4 and solve those. Problem 4 here, it looks like I've got a sum of cubes. This is an x cubed. Oops. Froze here for some reason. This is an x cubed plus a 5 cubed. And so it's going to factor as a plus b, a squared minus a b plus b squared. I'll let you solve it. Hopefully you get the idea. Now, when you get something that isn't a difference of perfect squares, like 12 is not a perfect square, neither is 27, no panic. Okay, our first step, if you remember from the first slide, is always look for a GCF, and 12 and 27 are both divisible by 3. So it becomes this, which is a difference of squares. So still go through your steps for factoring, which is get it in standard form, set it equal to 0, look for a GCF. I'm not going to work this one all the way through. We've seen a bunch like these now, or a couple. There's my A and B. 7's a little tricky. See how you can take an X out of both of them? So you're basically dividing by x here, but you're keeping track of that x out front. Hey, look at that difference of squares. So he factors some more. Most people don't realize it, but that's like an x squared minus 1 squared. It is a difference of squares, so you can do it. And the very last one, looks like everybody's divisible by 2. And it looks like I can take out an x. And then we've got ourselves a difference of cubes that can factor some more. That should do it and give you an overview of how to solve all of those homework problems.